Welcome back. Today we'll solve problem 11.30. So statement is using E is equal to 29 into 10 raised to the power 6 psi. Determine the strain energy due to bending for steel beam and loading shown. Ignore the effect of shear stresses. So you can see this beam AC is overhanging beam with support at point B and a roller support at point C, and this is W6 by 9 wide flange beam. So from A to B, this distance is 2 feet. From B to C, the distance is 8 feet. So you have to find the strain energy due to bending of steel beam. So let's start with the solution. So our first step is to find the reaction forces if we remove the support at point B. So if we remove the support at point B, so there will be reaction force at point B, and there will be a reaction force at point C. So I have denoted RC downward because you can see here that this force is downward, so this force will be upward and this force will be downward as well. So you can apply equilibrium condition to find these unknown forces. So I will write equilibrium conditions. The first condition is that sum of all movement about point B is equal to 0 and taking the counterclockwise movement as positive. So about point B, we have this force and perpendicular distance is this one, and this is producing counterclockwise movement, so it will be positive. And the second movement is due to this RC into perpendicular distance is this, and it is producing clockwise, so their sum must be equal to 0. So I will write 4 into 2 feet. So 2 feet is actually 2 feet is equal to 24 inch. So 2 into 24, this is 24 inch, 2 feet. Okay, minus RC into perpendicular distance is 8 feet. So 8 feet is equal to 12 8s are 96, which is 96 inch. So RC into 96, their sum must be equal to 0. So from here you will get RC is equal to 1 kips. So 1 kips, that is downward. Now you can apply the initial equilibrium condition, that is sum of all forces along y direction is equal to 0 and taking the upward force as positive. So one force is downward, the upper is up, RB is upward and RC is downward. Their sum must be equal to 0. So minus 4 plus RB minus RC, which is 1, is equal to 0. So it means that RB is equal to 5 kips. Now we have find out this reaction support, so we will find the bending. We will find the bending equation for portion AB. So for portion AB, so if you cut the portion AB and draw the free body diagram, so it will be like this. So this is your point A where we have the RA is downward, and that is 4 kips. Let this distance is X, and if we cut the beam, there will be a shear force and external moment M. So for finding, let this point is point 1. So applying the equilibrium condition, sum of all movement about point 1 is equal to 0 and taking the counterclockwise movement as positive. So about point 1, this force is producing movement, perpendicular distance is this, and this is producing counterclockwise, and one movement is this, again counterclockwise. So their sum must be equal to 0. So I will write it 4 into X plus M is equal to 0. So implies that M is equal to minus 4x, and the unit will be kips into inch. Okay, so this M is negative. It means that our direction we have taken counterclockwise is wrong. It should be clockwise. Okay, and this is valid for X is greater or equal to 0 and less or equal to 2 feet, which is 24 inch. Now this is the moment equation for portion AB. Now we will find the moment equation for portion BC. So for BC, we will cut the beam over here and we will take the distance from here is V. So I will draw it over here. So let this is the point C where we have one Gibbs force acting downward, and let this distance is V. And if you cut, there will be a shear force and there will be a bending moment. And for that, limit V is greater or equal to 0 and less or equal to 96 inch. I will show you. We start from here, V is equal to 0 and it till point B, this is 8 feet, which is 96 inch. Okay. So again, let this is point 2. So sum of all moment about point 2 is equal to 0 and taking the counterclockwise moment as positive. So you can see at point 2, the moment is due to 1 into perpendicular distance is V, and that is clockwise. And we have another moment that is also clockwise. So their sum must be equal to 0. So 1 into V, and that is minus M is equal to 0. So from here we will get moment is equal to minus 1 Gibbs into inch. Also, you can see that we have taken this moment as clockwise and we have taken the direction over minus, and M is minus 1 Gibbs. So it means that our assumed direction was wrong. So M should be in clockwise direction. Okay, so this is the bending moment equation. Now we know that total strain energy is equal to strain energy in portion AB plus strain energy in portion BC. So you can just put the value that is equal to integral of m square dx over 2ei, and limit will be 0 to 24 inch because this is 24, plus this will be equal to limit 0 to 96, and that will be m square dv. This is 1v. Okay, 1v. Okay, 2ei. Now you have the values, you can put it, you have all the values, but you do not have I. So W6 by 9, we will note down I value. I have already written it is 16.4 inch. 4 I will show you in a while, and E was given as 29 into 10 raised to the power 3 ksi. So let's move and I will show you E is 1.6, 1.64. So you have to go to the property table at the end, and this is in US customary unit. This is W6 by 9. So you have to search it. You can now see. Okay, so this is W6 and this is W6 and 9, and we have 16.4 inch power 4. So you have to note down. I have already written it. Now you can move and further simplify this. So U is equal to, it will be equal to, if you take this term, so it will be equal to 1 over 2ei integral of 0 to 24, and moment was minus 4x. So it will be minus 4x whole square into dx, plus other one will be, you can see 1 over, again if 1 over 2e is also common, so if I take it common, whole bracket, braces, okay, not braces, square bracket. Okay, so we will left with integral of 0 to 96, and that will be minus v square, because you can see this is minus v square into dv, and we are closing the square bracket. So from here this is 1 over 2 EI, and that will be equal to this term. After integrating and taking the limit, we will get 16 over 3 24 cube, plus from this you will get 1 over 3 1 over 3 96 cube. Okay, so if you further simplify it, you have already all the values, and if you further simplify it, you will get this 184,320 divided by EI. Now you can put the value 184,320 divided by E is 29 into 10 raised to power 3, and I is 16.4. So from here you will get 0.38755 kips into inch, or you can say that U is equal to 388 pounds into inch. So this is your answer of problem 11.30. I hope you have enjoyed this video. Again, if you have any question, you can ask me in comment section. Those who are new to my channel, then subscribe it and press the bell icon so that you can get the latest videos. Thank you for watching.